Hey everyone, and welcome. Today, we're diving into an incredible, true story of environmental success. It's about how all of humanity stared down a catastrophic threat to our planet and, somehow, against all odds, came together to fix it. This isn't just a history lesson, it's a genuine blueprint for hope. So try to imagine this. You look up and you realize that the very shield protecting all life on Earth is thinning out. That it's developing a massive, gaping hole over an entire continent. I mean, that was the shocking reality that scientists were facing. But what exactly is this planetary shield? Well, it's called the ozone layer. It's this concentration of ozone molecules way, way up in the stratosphere, about 15 to 30 kilometers above our heads. Something like 90% of all the ozone on our planet is up there, and it acts like a kind of invisible sunscreen, absorbing the most dangerous ultraviolet or UV rays from the sun. Okay, so how did this vital shield all of a sudden start to fall apart? The story actually begins with a chemical invention that, at the time, was seen as a total modern miracle. And here's the villain of our story, chlorofluorocarbons, or CFCs for short. These things were everywhere, in our refrigerators, our air conditioners, aerosol spray cans, and they were considered perfectly safe, mainly because they're incredibly stable and non-reactive, at least down here on the ground. But that stability, well, that turned out to be the exact problem. It meant they could survive the long journey all the way up to the stratosphere. Now, this is where it gets really crazy. What this slide shows is just a relentless cycle of destruction. Once those CFCs get up into the stratosphere, the intense UV radiation just blasts them apart, and that releases these super reactive chlorine atoms. A single one of these chlorine atoms then acts like a chemical Pac-Man. It just tears apart an ozone molecule and then moves on to the next one and the next and the next. The chlorine atom is a catalyst, right? It doesn't get used up in the reaction. Let's actually look at the data to see how bad it got. So in 1979, the ozone hole over Antarctica was already starting to form. Scientists measure how thick the ozone is in something called Dobson units. You can just think of it as a measure of density. That year, the thinnest point was 194 Dobson units. Now, for some context, a healthy, thick layer is usually anything above 220. So, not great. Now, fast forward just 8 years to 1987. The hole had absolutely exploded in size. We're talking over 22 million square kilometers. That's larger than the entire continent of North America. And the ozone layer itself was dangerously thin, dropping all the way to 109 Dobson units. This thing was accelerating at a terrifying pace. And here we see the absolute peak of the crisis. By 2006, the Antarctic ozone hole hit its largest size ever recorded, a staggering 29.6 million square kilometers. And the ozone levels, they bottomed out at a dangerously low 84 Dobson units. So how could this happen so fast? The answer is in this number, 100,000. A single chlorine atom, just one, can destroy over 100,000 ozone molecules before it's finally neutralized and removed from the stratosphere. It's that relentless catalytic cycle that explains why the damage was so unbelievably fast and so severe. But, okay, why does a thinner ozone layer matter so much? I mean, so what, right? Well, the answer lies in the different kinds of UV radiation the sun is constantly bombarding us with. So our atmosphere lets most of the UVA rays through, and those penetrate pretty deep into our skin. But it's the shorter wavelength UVB rays that are the real problem. They're what cause sunburn, and the ozone layer is our #1 defense against them. A hole in that layer, it's like opening a floodgate for all this harmful radiation to pour through. And the consequences of that were just dire. Scientists were projecting skyrocketing rates of skin cancer and cataracts in people. But the threat went so far beyond just us. More UVB radiation can damage essential crops like rice and soy. It can harm the phytoplankton at the very base of the ocean food web, and it even degrades materials like plastics. This wasn't just some abstract atmospheric problem. It was a threat to life itself. But this story is not about despair. Just as the world was staring into the abyss, something truly remarkable happened. Humanity decided to act. Just look at this timeline for a second. The response was astonishingly fast. After the hole was officially confirmed in 1985, it took just 2 years for the world's nations to come together, negotiate, and sign a historic treaty. In the world of international politics, that's moving at light speed. And that treaty was the Montreal Protocol. It's this landmark international agreement designed to completely phase out CFCs and all those other ozone-depleting substances. And it worked because it was both firm and flexible. It set binding targets, but it also created a fund to help developing countries make the switch. This spurred incredible innovation, and eventually, every single country in the world signed on. It's actually the first universally ratified treaty in the history of the United Nations. So, did it actually work? What is the legacy of this unprecedented global cooperation? Yes, it absolutely worked. Because of the Montreal Protocol, the ozone layer is slowly but surely healing. Scientists project it'll recover to its 1980 levels by around 2066 over the Antarctic, and even sooner than that in other parts of the world. We literally dodged a planetary bullet. The former UN Secretary General Kofi Annan called it perhaps the single most successful international environmental agreement to date. And, it's really hard to argue with that. It proved that global cooperation on huge environmental problems isn't just possible, it can be incredibly effective. And the success of the Montreal Protocol really reinforces this powerful idea. It all started with scientists who saw a problem, governments that actually listened, and everyday citizens who demanded action. It's a true testament to the power of thoughtful, committed people changing the world. And that leaves us with one final, and I think pretty powerful question. The ozone story gives us a clear blueprint for success. Listen to the science, act decisively, and cooperate on a global scale. If we did it once, what's really stopping us from applying those exact same lessons to the challenges we face today?